Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad RASYDAN bin RUSLIB with number matrix 2020859824. And today I would like to present my final year project, which on the topic of rain gutter energy harvest through a PICOHYDRO system application, supervised by Dr. Muhammad AZZEIM bin JUSOH. So as we can see in this slide here, this is my project outline, what I'm gonna talk about later on, which is we start with abstract. Uh, it's about a summary of my project. Next is introduction for my project, literature review, which I will talk about it later. And next is problem statement, the objectives for my project, scope of study that we're gonna cover for this presentation, methodology, expected results. As we can see, the findings from my project, references, and also lastly the conclusion. So in this section, we have my project summary. As I conclude here is my abstract. First, this study describes the design and development of PICOHYDRO system. Basically, I'm mainly focusing on the downspout and also energy storage to make sure that the system can run efficiently without any problem. So, and the next is basically my Pico system is attached to the gutter and pointed at a turbine that's situated at the lower places or lower elevation to make sure there is a potential energy that we can gain from the different height to collect energy from the gutter to through the potential energy that gain from the water flow. So next is basically my study and develop of the system will be tested through experiments, and the experiments are used to determine the system efficiency. All right. So before we go in depth, this is my introduction. Basically, how I come out with this idea is to the need for renewable energy sources is greatly increasing in demand because of the reduced reliance on fossil fuels and mitigate the negative effects of climate change is the main important things for as for current era. So basically, how I implement this system, basically I create a PICOHYDRO system, which is the best alternative that I could think to be implemented. And basically, my study is focusing on the residential areas. To systematically relate all the components in the project, the rain gutter energy harvest system can be divided into three main parts: the water collection system, the turbine, and the generator. Basically, there is the energy storage and also distribution system to make sure that our system can be functioning well. So in this section, what I'm gonna telling about is a literature review. So basically, literature review. What from the previous researchers, I review all the papers and choose and pick the most related ones. So basically, there is two main components that I'm want to develop, which is a downspot design, also the energy storage design. So basically, for the downspot design, uh, I use a buffer, a passive rainwater buffer. Basically, there is a siphon valve mechanism inside it to make sure that the water turbines can be run properly through potential energy from the rainwater. A small-scale experimental prototype was built to validate the energy harvesting performance of the proposed structure. Next is due to elevational variance, stream flow in the rain gutter system has a potential energy. Using the PICOHYDRO generator, the potential energy might be transformed into electrical energy for home usage uh, and also the storage. The turbine in the PICOHYDRO system will be struck by the stream flow with potential energy, rotating it while driving the generator to produce electricity. So next is for the energy storage design. Previous studies for the turbine system also shows a user-friendly PICOHYDRO system with a smart energy storage battery management system. So what is actually can do? So basically, there is they keep all the energies from the turbine and put it in a one system with one management system, so that you can use it later. And the next reference that I chose was the output stability of the PICOHYDRO generator module can be enhanced with a stabilizer in the form of DC to DC converter system so that it can reach a stable voltage of 5 volts. Basically, what I'm trying to say here is basically I want to create energy storage management to make sure that this energy reduced from any losses and it can be effectively collected. So in this section, I'm talking about a problem statement that I have been found during the review from the previous research or even the current machines that we have for the harvesting method. So basically, the first problem that I have been found out, which is the existing design and parameter of gutter along the downspout does not practically support gutter and harvesting method. Next, current urban pico-hydro system were not fully utilized, which battery system have to be developed to attain this energy. We have to prevent losses from wasting any energy that we have harvest from the rain. So basically, I will introduce a new battery system management that can fully occupied this method. And the next thing is the direct flow from the spot could be insufficient unless a storage medium is introduced. What I'm trying to introduce here is a system where a storage medium will be used with a usage of siphon buffer. So basically, for my studies and development, there is three objectives that I have been found during my studies. So the first objective that I aim to is to design a pico-hydro system that is capable to extract energy from the gutter system. And my next objective is to develop an optimized energy storage system to make sure energy losses would not happen so frequently. And the third thing is to perform optimization of pico-hydro for rain gutter application into getting the maximum rainwater velocity for turbine striking. So this three main objective is very important to meet it all to make sure my project will be a successful. So for my scope of study, first I will make sure the system able to be implemented in housing standard gutter design. And next thing is I'm going to focusing on buffer application, turbine, and energy storage design. The last for my studies is the following: every standard design for rain gutter are in a right procedure in a following every national standard for a rain gutter design. All right, so in this part, we have a methodology. First, I'm starting with the conceptual design. What I'm going to do here is I'm finding a problem statement from the previous research or the current system that have been implemented. The next thing is I'm going to find my objective to fully satisfy my proposal. Next is literature review, reviewing all the research papers that are related to my studies. And lastly, a proof of concept that I'm going to introduce in my system, such as the siphon bell mechanism and a smart battery system. And the next thing is a preliminary design. As we can see in the left is some part of my for my design, which I'm using a CATIA V5 to create a 3D modeling for my turbine and also some parts for my siphon bells and schematic drawing for circuit and also my whole system. So the next step is experimentation. What I'm gonna do I'm gonna create an experiment, raw experiment to make sure everything can be run smoothly and to see if it's fully satisfied or it doesn't. If it is fully satisfied all the above condition, I'm gonna goes on with the result and analysis. And with the results that we obtain from the experiment, we're gonna discuss it about later. And that is the last step for my methodology. I'm gonna add up more in depth about mechanical electric conversion. Basically, what I'm gonna do here is do from the turbine shaft that have been striking from the water of the from the rain, and it goes to the DC motor, and a buck boost converter will be used to convert DC to DC power. It goes to battery changer module, and lastly, it stores in a Li-ion battery. So for my results section, I'm gonna show first process of 3D drawing I have made by using a CATIA V5 software, and next and the assembly of the mechanism, which is a siphon bell mechanism, and the last part is a raw experimental that I've been done to make sure this uh, a proof of concept is fully satisfied. The detailed design has been completed and able to be assembled with piping for fieldwork experimentation. The water flow, how it works, it will hit the turbine at highest velocity from the vacuum process that occurred inside the siphon bell. So within these results, I'm expected to make sure that everything it can be run properly within the range of system that I have been made. All right, so basically these are the list of references that I've been using to complete my proposal and also to complete my project. There is about a 10 references that I have been used to make sure that my project can be done fluently. So as for my conclusion, using a PICOHYDRO system for rain-gate energy harvesting can be a cost-effective and sustainable way to generate electricity. It is very important to carefully consider the specific requirements and constraints of the site where the system will be installed, as well as the local regulations and costs that may apply. With careful planning and design, it is very possible to successfully implement a PICOHYDRO system for rain-gate energy harvesting and realize the benefits of this technology. So that's all from me. Thank you.